So today we're going to cover section 5 and we're going to talk about angles. First thing we're going to do is define what an angle is. And an angle is formed by two rays that have the same endpoint. The rays are called the sides of the angle, and the common endpoint is called the vertex of the angle. In this picture, there are three ways that we can name an angle. We can name it by its vertex. We can name it by using the 3 points, or if the angle was labeled with a number, we could also name it with that number. So let's say in this picture here at the bottom, let's say I put the number 1 in here, I could also call this angle 1. Now, notice what they've done when they named it with the 3 letters. They start here, and then they go to the vertex, and then to the other side. So it would be named MNO, or we could go from O to N to M. We could reverse it. Notice the middle letter is that vertex. It's where the two rays meet. Now, because there's only one angle sitting here, I can also label it with its vertex. If I had another ray, and there were more than one angle here with a vertex of N, I would have to use 3 letters. And you're going to see that on the next slide. Okay, so when the vertex is shared, you have to use the 3 points. So in this picture, there are actually 3 different angles happening. The first one is the large one. If I were to name it A, B, C, and again, this little symbol represents the word angle. You either need to write the word angle in front or this slanty L looking thing. So I can call that first one angle A, B, C, or I could reverse the letters and call it CBA. B must be the middle letter. Then I've got another that's pictured here, is this one right here, ABD. So again, you would name that one as ABD or reverse the letters, DBA. And then I have a third angle pictured here, and that could be DBC. And again, B is the middle letter, or I could reverse it and call it CBD. On all of the 3 angles pictured there, the blue, the red, and the black, notice all of them are described as having angle B, the vertex, in the middle. You can't just call the angles that's pictured here as angle B with 1 letter, because there's 3 different angles here that have that vertex of a B. Now, if they had numbers, let's say I call the blue one angle 1, and then the red one angle 2, I could have also called ABD angle 1, and this one angle 2. Now, you can't just add numbers yourself. It would have already had to have been pictured there. Now, the way that you're going to distinguish between that one being a name for the angle versus its measure, whenever they're going to tell you the measurement of an angle, it's going to have a degree symbol. So for example, let's say they told you this was a 20-degree angle. It would have a 20 with the little circle at the top, which is the degree symbol. But we're going to talk about the degrees in a minute. So the next one is talking about the interior and the exterior parts of the angle. So the region that contains all the points between the sides of the angle is called the interior of the angle. And that would be the red in the picture. The region that contains all the points outside the angle is called the exterior of the angle, and that would be the blue part. The next slide has another postulate. This is similar to the ruler postulate. So just like they said the numbers could be paired 1 to 1, same thing here on the protractor. We can pair the numbers 1 to 1 from 0 to 180 degrees. Now, we can use this tool to measure angles. We're not going to be buying the plastic protractors and actually measuring angles. However, be aware of how to read a protractor, because I may give you a picture like this and I may say, what is the measure of angle AOB? And I'm going to show you how you would use this tool. So notice there's two rows of numbers. You have the ones along the outside edge, and then there's some inside numbers. Now, if you've ever seen a protractor, it's usually a plastic like ruler, but instead it's a protractor. And usually in the center here was always a hole. And what you would do if you were actually measuring an angle with your protractor is you would have the angle that's drawn, and here I have this angle AOB, and I would take my protractor and put it on top of my paper, and I would make sure that the hole in my protractor was lined up with that vertex. Now, when your angle measure is got a ray that points to the right, so you see how this ray is pointing to the right, I'm going to be using the inside numbers here to measure this angle. Because if you think about it logically, to measure this angle, I'm starting at 0, and then I'm counting up until I get to the other ray where the angle stops. And if you notice, the number where it stops at is 140 degrees. Now let's say I drew in another ray, and let's say I draw it in this direction. And when you do this and you actually have a protractor, there's actually like a black line that you're lining up your side of your angle, the ray with that black line, as well as the vertex with the hole in the protractor. Now, if I wanted to measure this angle, when it points to the left of that hole, then you're going to be using the outside numbers, because again, you're starting at 0 and counting up. So here, if I wanted to measure this, I'm going to go until where it stops. And let's say I call this angle AOC. I'm going to start with 0 and count up until I hit the 40 degrees. So this angle AOC would be 40 degrees. Now what we're going to see coming up on the next slide is that this ray here, along with this one pointing in this direction, are going to be a straight angle. And a straight angle has 180 degrees. So if you wanted to double check, if they ask you to find both of these missing angles, you can double check your answer by adding 140 plus 40. And if it didn't add up to be 180, that meant you did something wrong. Now again, the little M that's in front of this little angle symbol, this little M represents the word measure. So whenever you see the little M in front, they actually want you to figure out how big that angle is. So let's go ahead and classify some angle measures on the next slide. So the next slide again is talking about the protractor. And again, remember the protractor is just a tool that you're going to use to measure angles. Now in this course, for the whole first semester, any angle we measure is going to be in degrees. Another unit of measure to measure angles would be radians. And we'll talk about that after Christmas. Next year, when you take Algebra 2, you're going to also be dealing with angles when we cover trigonometry. And we work with the angles in both degrees and radians. So a little preview of what's to come after Christmas. Now, there are 4 classifications that we can give the angles. And when your angle measures between 0 and 90 degrees, this is called an acute angle. So if you think about it, if you were to say take the word acute and split it up, and say that it's a cute little angle, you know it's a small angle. It's an angle that measures between 0 and 90 degrees. When we have a right angle, it will always measure exactly 90 degrees. Now, whenever you're given a picture of a right angle, you're going to need to look for this little square indicating it's a right angle, or they're going to need to tell you that it measures 90 degrees. If you just see two rays and it looks like it's forming a 90-degree angle, you can't assume that this is 90 degrees. You would need to have the little box, or they would have needed to tell you that it measures 90. Or later on coming up, we're also going to learn that if two lines are perpendicular, they also form right angles. Then the next name or classification is obtuse, and this will be an angle that measures between 90 and 180 degrees. So it's going to be a little bit bigger. It could be like this. Again, I always use this, the 90 degrees, as a good reference point because if it opens up wider than that, it's obtuse. If it squeezes in tinier, so for example, the acute would be definitely squeezed in more from the 90 degrees. And then again, the straight angle is always 180. This is the only one that you can assume. So if they told us that this is angle or line AB, then you should also realize that line AB is a straight angle and it measures 180 degrees. That's the only thing you can assume in geometry without being given a number. If it's a straight line, it measures 180. So let's practice using the protractor. All right, so now we're going to practice with this protractor. I'm going to go ahead and highlight the angle they're referring to. So I'm going to highlight angle GHK in red. And again, I go in order of the letters. So G to H to K. Notice my one side of my angle is pointing to the left. So I'm going to start at 0 and go from this ray to this ray and see where it stops using the outside numbers because I don't want to count backwards. I'm going 0, 10, 20, 30, all the way up. And it's halfway in between 120 and 130. So this is a 125-degree angle, making it obtuse because it's between 90 and 180. Now for GHL, I'm going to go ahead, start at JHL, go here from J to H to L, and it goes up to the 90. Again, I'm using inside numbers because I start at 0 and then go to where the other ray is, and it's pointing at the 90. For that one, it really wouldn't have mattered because notice both numbers are 90s here. But again, you want to start at 0 and count up. And this would be a right angle because it measures exactly 90. Now, for the last one here, you're going to see that it's not pointing at the 0. So what we're going to have to do is subtract two of the numbers for this one. So LHK, go from L to H to K, and I'm going to see where these two sides of my angle are pointing. And I could either use the two inside numbers to subtract or the two outside. So if I wanted to do 90 minus the 55, where they're hitting, this is going to give me 35. Or I could have also done the 125 minus the 90. So this would have been using the two outside numbers. This would have been the two inside numbers. Either way, I get 35 degrees for that angle. And because it's less than 90 but greater than 0, it's an acute angle. Next, congruent angles are just angles with equal measure. And again, on this one, the measure of angle A equals the measure of angle D. Generally, if they write something like that, they're going to tell you how much A is and how much D is. So let's say in this picture, I told you angle A was 20 degrees, then that would mean angle D here is also 20. Now, when they give the congruency statement, I'm really not interested in knowing how much it measures. I just need to know that they're the same. And again, they'll use congruency marks. Instead of the little dashes or the tick marks, the angle measures are going to be with like a little arc or a little curve to them. So a congruency mark on an angle would be like a little arc here, just like this line that's here. And they'll have the same identical marking to show that two angles are congruent. All right, next one. Again, don't memorize the number. You can memorize the name. This one's the angle addition postulate, similar to the segment addition postulate. Remember when you took two little segments and you added them together, it'll make a larger segment. Same thing here with the angles. If I were to take angle AOB here and add it to BOC, that will give me the measure of the entire angle AOB. So I can take two little pieces and add them together to get a larger angle. Or if they gave me the whole thing and one of the small ones, I could subtract to find it. Now, if your angle is a straight angle and point M is any point not on JK, then we could show that the measure of JKM plus the measure of MKL is always going to add up to be 180, as long as this is a straight angle. What we're going to see later on, that these are supplements, and that'll be in tomorrow's lesson. But let's say I told you that the measure of JKM was 110. And let's say I asked you to find what is the measure of MKL. What we would do is set up an algebraic equation, and we would do 110 plus x and set that equal to 180. And then to find the missing angle, I subtract 110 from 180 and x equals 70. So this missing angle would be 70 degrees. And again, one way you can check yourself is that 110 plus 70, if that doesn't equal 180, you've done something wrong. Okay, so an angle bisector is just a ray that's going to divide the angle into two congruent adjacent angles. Now, if you think about the word adjacent, not necessarily in terms of math, adjacent means next to. So two adjacent angles are two angles that are next to each other. So if you have your original large angle, ABC here, and then if you have this ray BD that comes along and splits that large angle into two congruent pieces, that's how we can tell that that original angle was bisected. Now, in order to tell if something was bisected, they're either going to need to give you angle measures, like they did here, and show you that they're both the same measure, 20 and 20, or it's going to have congruency marks, and it would have the same marking on both angles. So you can't just tell that something was split. So if I have a picture like this, and I call this ABC, and if I draw a ray right in the middle, I can't tell that this thing has been bisected without any numbers or markings. I would either have needed to have been told that this was congruent to this with markings, or they'd have to give me numbers. And they'd have to have the same number in each of the little angles. Next slide is about congruency marks. I know we've talked about them already. So here they're just reviewing segment congruency marks. So here it would show that AE would be congruent to ED because they have the same mark. And now instead of little dashes, when they have congruency marks on angles, they're going to be this little arc looking thing. So I could show that this angle AEB is going to be congruent to BEC because they both have the same congruency mark. And then the right angle mark is always that little square. So let's say I had so if I have two lines and they cross, and I could show that this angle would be congruent to this because it would have the same mark. And then I could show that this one is congruent to this one. And we're going to learn what these are called, but just know that you're looking for pictures and you're looking for the markings to be the same. Now, it may not be in color. Just know that you would count the lines to see which ones match. Now let's just do 2 examples, or actually 10 examples, and then we're done. All right, so this one, it wants us to give another name for each angle. Now, some of these have more than one, but if ever on a test or a quiz I ask you to just give me one other name, just give me one. Don't give me more than one, because if you give me more than one and one is wrong, you're going to get the question wrong. But I'm going to give you all of the options here, and know that if this were your test question, you could just pick one of them. So another name for DEB, and let me go ahead and outline it. And you go in the order. So D to E to B. Remember, we can name this angle by reversing the letters. We can also call it BED. And because they gave us a number here, I could also call this angle 4. Now, if you remember that the sides of an angle are formed by a ray, this ray right here, ED, keeps on going all the way to C. So I could also have called this angle CEB, or reverse it as well. So again, any point that's on that ray would be a way to name the angle. Now the next one, CBE. So I'm going to start at C, and then I'm going to go to B, and then to E. So C to B to E. Now for this one, I can use the number that's there or reverse the letters. So EBC or angle 8. That only has 2. Next one is BEA. And again, I'm going to start at B and then go to E and then down to the A. So again, I can reverse the letters. That would be another name. And in this case, it also has a number. I could call it angle 3. The next one, angle DAB. Let me find that one. Again, start at D, and then you're going to go to A, and then to the B. So for this one, it's got a number there. I can call it angle 1. I can also reverse the letters. I can call it BAD. And again, remember this ray here keeps on going. So I could also call this angle CAD or reverse the letter. I could also call it DAC. Either way. Now angle 7. Angle 7 is right here. What am I doing green? So 7 is here. So I need to get the rays that are going to form it. So I can take it out this way. So for angle 7, this one's got a lot. So let me go ahead and for number 5, and this is the green. So this was angle 7. So for this one, I could either start at ECB, do it in black so it shows up better, ECB. I could also reverse the letter and I could call it BCE, or I could do and not stop at B, go all the way to A, so ECA. Then I could reverse the letters. So let's see, I could also do ACE or BCE here. I could also, since there's only one C here, I could get away with one letter on this one. And then I could also do starting at the D and go to D to C. So I could go DCB, so angle DCB. And we could also go all the way to the E. So we could also do angle BC. No, I already said that one. Let me fix that. DCB. Well, you could do BCD, any order there. And now angle 9. Let me get another color here. So for angle 9, it's right here. So again, we're going to take the sides and extend them out. So for angle 9, there's only 2. We can either say it's ABE or reverse it EBA. Now for 7, 8, and 9, they want us to use our angle addition postulate, and once we put 1 and 2 together, what letters is forming that angle. So for there, let's see if I can get maybe yellow. All right, so 1 and 2 together are over here. So the angle that's, or the rays that surround that are going to be EAB, or we could even take it as far as EAC. Now again, we can also reverse these, BEA, BAE or CAE. So this is for number 7. Then for number 8, and these are all the yellow that I just outlined. Three and 4 are up here. So again, take the rays or the sides. So for number 8, we can call that either AED, or we can reverse it, DEA, or we can call it AEC, or again, reverse it, CEA. And then the last one, this is this straight angle over here, 5 and 6. So for number 9, we can either call this EDC, it's a straight angle, or reverse it, CDE. So that is a straight angle, and it measures 180 degrees. All right, last one. So it says, given that LKN measures 145, so this whole thing is 145. They want us to find the measure of LKM and MKN. So what I'm going to do is I know that the measure of LKN is equal to the measure of LKM plus the measure of MKN. So let me replace what I know. I know this one's 145. I know that LKM is 2x plus 10. And MKN is going to be 4x minus 3. I now need to solve this algebraic equation. I'm going to combine like terms. That'll give me 6x. Then I can combine the 10 and the 3. Gives me 7. I'm setting it equal to the 145. Subtract 7. I get 138 is equal to 6x. Divide by 6. And x equals 23. Now, it didn't say to find x. It wants me to find these two measures. So the measure of LKM is 2x plus 10. I'm replacing x with 23. I'm going to multiply and add. And LKM is 56. And now measure of MKN, that is 4x minus 3. Again, replace x with 23. I'm going to multiply. I get 92. Subtract 3. And MKN is 89 degrees. Now, one way you can check this is add 56 plus 89. If this does not add up to be 145, you have done something wrong. So you should go back and recheck your value of x. And that is it.